Today, lesson 33B, scale and scale drawings. We continue with dealing with problems that have proportional relationships. Yesterday, we learned how to find a missing side of a similar figure to create a proportional relationship. Well, today, very similar to this, except we're going to talk about scale and scale drawings. But once again, the idea is to try and find a missing value to create a proportional relationship. So let's go ahead and get started. This is what we talked about yesterday. And remember, yesterday we were trying to figure out what value would have to be substituted for x to create a proportional relationship. And we used a proportion to figure that out. And there were 4 different ways that you could set up a proportion. Here was the one that we used for this yesterday. And then we just solved the proportion the same way we've been doing for quite some time now. And so what that means is that when this side is 28, we have a proportional relationship. And sometimes we're enlarging figures like we are here. Sometimes we are reducing them. All right, a scale. And this is where you have some spots to fill in your notes. It's the ratio, and once again, this term ratio keeps coming back, between the length or a length of the representation, such as a map, a model, or a drawing, and we're going to see all 3 of those today, and the corresponding length of the actual object. So that's scale. And also, today we're going to deal with scale drawings. And here's another spot where you need to fill something in. Scale drawing is representations of real objects or places that are in proportion to the objects or places they represent. Maps and blueprints are examples of scale drawings. So we have another spot that we need to fill in our notes here. And today we're going to see, in fact, if you look at number 1, we have a map. And number 2, we have a scale drawing. And I believe it's number 4, we have a blueprint. So we're going to deal with all of these things today. And I think it's actually number 6 where there's a blueprint there. And I know it's hard to see. Hopefully on the lesson today you'll be able to see what that is. All right, so let's move on here. Here's number 1. It's a map of the United States. And what we're trying to figure out is the actual distance from Los Angeles to Houston. And the scale on the map, you can see every inch on the map represents 300 miles in real life. Now, how do I know that? Because of this valuable piece of information right here. And it is this part right here that helps us tremendously, because that's the first ratio that we're going to use to figure out what that actual distance is. So, there's the scale right there. And so we can see that there's 1 inch right there, 2 inches right there, 3 inches right there, 4 inches right there. So on the map, it's 5 inches from Los Angeles to Houston. 5 inches. And so what we do is we use our scale here, and the 1 inch represents the map distance. For every 1 inch, it's 300 miles of actual distance, or in real life. And from here, and just to kind of explain what the scale means, 1 inch distance on the map represents 300 miles of actual distance. So we're going to use the ratio of the 1 inch over 300 miles. So I'm going to stop for a second to let you copy that down. Okay, so from here, we need to figure out how many actual miles it is when our map distance is 5 inches. So let's finish off our proportion here. And so where did I get these numbers? The 1 inch is right here. This was 5 inches on the map right here. That's where I got the 5 right here. And notice that both of my map distances are on top, much like many of the word problems that we've dealt with. This 300 is in miles, and we're trying to figure out how many miles it would be. And of course, when we do that, we will have a proportional relationship. Could I get everybody to solve that proportion, please? This. All right, so we have to use the upside down property. And then we multiply both sides by 5. We've solved many, many proportions at this point. And we should get 1,500 over 1 or 1,500. So that means that 5 inches on the map represents 1,500 miles in real life. But much like the way we started yesterday, I'm going to make you take these values, put them in a table, and we're going to make sure that this is a proportional relationship. I'm going to help you through number 1 here. So let's take a look at our table, and let's go ahead and fill it in. So our very first ratio here, coming from this, or coming from our scale, will end up going right here. So 1 inch on the map is 300 miles in real life. And then we check our ratio of, remember, we're still using y over x. It's no different. These are our ratios y over x. And then we're going to do the same thing with the other two values that we got. 5 inches on the map is 1,500 miles. And if we write that as a ratio of y over x, we get 300 over 1. So you can see, since our ratios are equivalent to each other, we did find the right value. This is a proportional relationship. We're just sort of tying it together to what we've been doing for quite some time now. All right, any questions about number 1? That should seem easy. All right. Ratios are equivalent. This proves that this is a proportional relationship, and I did already kind of mention that. All right, so let's take a look at number 2. Number 2, we have a car here. The name for this car is a speedster. We are supposed to find the actual length of the speedster. We have our scale there, and our scale is 1 inch to 2.5 feet. Can I get all of you to circle that? Because that's a very valuable piece of information within this problem. Find the scale that gives you half of what you need there. And in fact, if you wanted to go ahead and fill that in your table, you could go ahead and do that. 1 inch on the drawing is 2.5 feet in actual length. All right, so here's what we have here. You can see that the car drawing is 4 inches by the ruler there. What we need to do now is we need to find out how long is that car in actual length. The scale is 1 inch, is 2.5 feet in real life. On the drawing it's 4 inches. How long is the car in real life? I want you to figure that out, please. So we take our scale. We know the car length on the drawing is 4 inches. And we use our scale, and it doesn't matter how tall it is because we're not concerned about that. That scale tells us that for every 1 inch of the drawing, it represents 2.5 feet of actual length. And we're going to use that for our first ratio. So we have 1 over 2.5. And that's going to be equal to 4 over x because the drawing distance is 4 inches. From there, use the upside down property. The solving part should not be difficult. And that tells us that the car is actually 10 feet long. Let's now go to our table. And let's prove that this is a proportional relationship. So we have 1 inch on the drawing is 2.5. In actual, that ratio is 5 over 2 or 2.5, depending on how you look at it. And the 10 over 4 is also 2.5 or 5 over 2. So we can see these two ratios are equivalent. That means this is a proportional relationship. So sometimes we have a map, sometimes we have a drawing, and sometimes we have nothing other than a word problem, like number 3. The scale on a map reads 8 centimeters to 200 meters. Find the actual distance if the distance measured on the map is 12 centimeters. I'm going to let you try and figure that one out. The scale on a map reads 8 centimeters is the same as 200 meters of actual distance. So find the actual distance if the distance measured on the map is 12 centimeters. So you have to locate the scale first. The scale gives you your first ratio or your first fraction. So that scale means 8 centimeters of distance on the map represents 200 meters of actual distance. So we take the scale. That's our first ratio. Notice that we have map distance in centimeters on top, and actual distance, which are in meters, are located on the bottom. And that tells us that that 12 centimeters, which is map distance, has to go on top of our next ratio, and then we just solve the proportion. We'll have to use the upside down property and do all these things we've talked about many, many times, and we get x equals 300, and that represents 300 meters. And I was glad to see that most of you realized that it had to be meters. So now let's check our ratios in our table. First one is 8 centimeters to 200. It's x over y. Or excuse me, y over x. I said x over y because as I'm walking around, 2 or 3 of you are still not writing your ratios the right way. We need to make sure that we do that. It's y over x, not x over y. That simplifies to 25 or 25 over 1. We take our 12 and 300. It's going to be 300 over 12, which is also 25 or 25 over 1. Our ratios are equivalent. That means this is a proportional relationship. Okay, any questions about this one? Yes? All right, let's take a look at number 4. Number 4 says the scale of a map is 2 centimeters to 15 kilometers. Find the actual distance if the map distance is 16 centimeters. I'll give you about a minute to a minute and a half to get this one finished. So let's take a look at number 4. Our scale is extremely important in a scale problem, and its 2 centimeters is the same as 15 kilometers of actual distance. 2 centimeters, once again, of distance on the map represents 15 kilometers of actual distance. So we utilize map distance, or I'm using map distance over actual distance to set up my ratios. We have 2 over 15 from the given ratio there, the given scale. And we're finding the actual distance when the map distance is 16. So there's a proportion I could use to solve. If I'm going to set it up like that, I have to use the upside down property, then multiply both sides by 16. That's the multiplication property of equality. And I should get 120, and it should be 120 kilometers. Any questions about the actual distance for this one? All right, so now table. The scale, 2 centimeters to 15 kilometers. As a ratio, it is 15 over 2. Once again, there still are a couple of you who are just randomly doing your ratios whatever way you want, it seems like. That's not how we've defined it. This column is typically x. This column is typically y. And our ratios are always y over x. Y over x. Some of you converted it to 7.5 or 7.5. You don't need to. Just leave it like that. That's fine. And then I take the 16 centimeters on the map and the 120 of actual distance, which is what I just found, and I simplify that. I get 15 over 2. So this tells me, since my ratios are equivalent, this is a proportional relationship. All right, so let's now take a look at number 5. A scale drawing has a scale of 1/2 inch to 10 feet. Find the length on the drawing for an actual length of 25 feet. All right, so we set up our proportion. That means that 1/2 inch of distance on the drawing represents 10 feet of actual distance. We use our scale, and I went ahead and converted 1/2 inch to 0.5 to make our math a little bit better. 25 feet obviously has to go on the bottom because that's an actual distance. Solve the proportion, and that would end up being 12.5 over 10, so we can't have a decimal within a fraction. We've got to divide that out. That should be 1.25. And let's go ahead and plug everything we need to into the table. I told you didn't have to do that to save time, but let's go ahead and do it really quickly right now. We can see that our ratios are equivalent, and that means that this is a proportional relationship. Any questions with number 5? All right, last problem for today. I know it's kind of hard to see in your notes, and it's actually kind of hard to see up there, but it's gray background and it's a blue. It's called a blueprint because the print on the actual drawing is in blue, and you can see it's the outline of a house there. So the scale of the house blueprint below is 3 inches, is 16 feet. If the actual length of the house is 80 feet, find the map length. This should be easy. Go ahead and figure it out. In problem number 6, we're trying to find the map length if the actual house is 80 feet long. We use our scale of 3 inches on the map is 16 feet of actual distance, and that helps us set up our proportion. And so our proportion would look something like this. 3 over 16 equals x over 80. That should be self-explanatory. From there, I multiply both sides by 80, and I get 240 over 16, which ends up being 15. So that means if the actual length of the house is 15 feet, or 80 feet, excuse me, the map length is 15 inches. Any questions on the 15 inches part? Let's fill in our table. Ratio on the first one is 16/3. The ratio on the second one also simplifies to 16/3. That means, since the ratios are equivalent, we have a proportional relationship.